Hey everyone, continuing on our discussion with wave phenomena, we're going to talk about refraction. Now, we're not going to talk about refraction right now, but we're going to lay down the foundation so that we can talk about refraction later on. Oh, that's not what I wanted. All right. So, with refraction, we have this thing called index of refraction. Now, index of refraction is a measurement of a material's ability to, I guess you could say, slow down light as it travels through it. So as light travels through mediums other than a vacuum of space, it's going to move at a somewhat slower speed. Now, the higher the index of refraction, the slower light travels in it. On the reference table, you do have indexes of refractions. It's on page 2. You have air, which is given an index of refraction of 1. That's a rounded phrase. So light is, for the most part, traveling the same speed in air as it does in a vacuum. But then we have something like diamond, which has an index of refraction of 2.42, where so that light's going to travel significantly slower by this amount in diamonds. Um, the speed of light is actually given right here. Speed of light in a vacuum is 3 times 10 to the 8th meters per second. Now, I do want to point out that speed of light in a vacuum is the same as the speed of light in air. One other thing that I want to note, there's no unit for the index of refraction. It's unitless. But you'll notice up here it says this. This is really meant to say that these numbers only work for this frequency, which is actually looking at yellow light. So uh, this is only for this frequency. You won't have to do anything else with a different frequency, but basically what happens is when you have different colors of light passing through these materials, the index of refraction is going to change accordingly. So, for example, a violet light would have a slightly different index of refraction than red light. All right. Um, Now, we have the equation V equals F lambda. So of those two things, lambda and frequency, wavelength and frequency, one of them has to change. So as light travels into a new medium that has a higher index of refraction, it's going to move at a slower speed. So the speed decreases. It turns out that the wavelength will also decrease, meaning that the frequency will always remain the same. So you send a red light of a certain frequency through air and it strikes a glass surface, it's going to move through there with the exact same frequency. Then if it goes into water, it moves with the same frequency. The frequency never changes unless you actively change the frequency itself. Now, there are two main equations for refraction. The main one is this, n equals c over v. N is representing the index of refraction, again, unitless. C is the speed of light in a vacuum. This is the 3 times 10 to the 8th. And V is the speed of light in the material. So, for example, if we are using diamonds, so N is 2.42, the C value will still be 3 times 10 to the 8th. It's constant, hence the C. But the V is going to refer to the speed of the light in the diamond. The second one is this. N2 over N1 equals V1 over V2 equals lambda 1 over lambda 2. This is meant for when you have like two different mediums. So you have um, something like corn oil and flint glass, and they want to know about wavelengths or something. The one thing that I want to mention though is just pay attention to these units, these subscripts. 2, 1, 1, 2, 1, 2. So what I usually do is if I know what the two materials are, like let's say it's corn oil and flint glass, what I'll do is I'll write this equation and then everywhere I see a 1, I'll just write flint glass, and everywhere I see a 2, I'll write corn oil so I don't forget. Just make sure that you're reading this straight from the reference table when you write it down. Because again, if you have one of these flipped, you're going to get the completely different answer. All right, so you can pause this video, work on this yourself, and we'll go over in a second. All right, So they want us to first figure out the index of refraction of the plastic. So I'm going to use n equals c over v. I know that the index of the speed of light in a vacuum is 3 times 10 to the eighth. And then they tell me that the speed of light in the plastic is 2 times 10 to the eighth. So 3 divided by 2 is 1.5, which when I look at the reference table gives me 1.5 is lucite. So this is could be a piece of lucite. Um, these indexes aren't unique, so there are actually materials that have the same index of refraction. So that's the best we could say. All right, so that is part B. Here's the next question. Pause the video, we'll work on it in a second. We'll go over it in a second. All right, here we have the index of refraction as 2.3, and we want to figure out the speed of light in that material. So once again, n equals c over v. 2.3, 3 times 10 to the eighth, and we're looking for v. So I'm going to put this over 1. I'm going to cross multiply. 2.3v equals 3 times 10 to the eighth. Divide both sides by 2.3. And I get 1.3 times 10 to the eighth. I know I did this right because I get a speed that is less than 3. If you get a speed that is greater than 3, you've broken physics. And if you get an index of refraction that's less than 1, you've also broken physics. All right, and then this should be the last question. So pause the video, work on yourself, and we'll go over in a second. So this one requires me to use that awkward equation. So n2 over n1, lambda 1 over lambda 2. And then what I'm going to do is the two materials that they have are air and diamond. So what I'm going to do is everywhere that I see a 2, I'm going to write air. Oh, where is my, there it is. Air and air. And everywhere I see a 1, I'm going to write diamond. All right, now I plug my numbers in. Index of air is 1. Index of diamond is 2.42. The wavelength in diamond is what I'm looking for. And the wavelength in air is 5.89 times 10 to the negative 7. So once again, I can cross multiply. And what I should end up getting is 5.89 times 10 to the negative 7 divided by 2.42. And you should get 2.43 times 10 to the negative 7. All right. If you have any questions on any of this stuff, please let me know. Otherwise, I'll see you later.